Hello and welcome to another mathematical studies video. We're going to talk about how to represent two line equations. So what happens when we represent both of them? Now realize that I have y and x. So I have two variables and two equations. The gradient of the first one is 2 and the y-axis point is 1 and minus 1 minus 2 for the other one. So if we represent them, we're going to get the following lines. This would be the first one and this would be the second one. Now obviously these two lines are crossing at a point. Let's find out what points that is. It's minus 1, minus 1. Now that means that both lines contain point minus 1, minus 1. So if you think about it, it means that, well, of course, minus 1, minus 1, if I substitute in the first equation, put x is minus 1, I'm going to get that y is equal to minus 1. And if I do it in the second equation, I'm also going to get minus 1. Both lines contain point minus 1, minus 1. Now, why is this relevant? Why is this so important? Well, let's check it out. Like what does simultaneous equations mean? It just means two equations that go together. Go together, very important. They have two variables, like these ones. And we normally symbolize that they go together by putting that symbol there. Now, there's one relevant thing that has to be said about them too. First of all, if they're parallel, they will have no point in common. However, if they're not parallel, they will just simply have only one point in common. There's another case which I'm not going to really specify on, which could be that this is actually the same line, but that's really not very relevant. So how do I solve simultaneous equations? Well, the only thing I have to do, I'm going to go through a method, and I could have done this in a different method which is much quicker here, but I want to use this method which is called substitution because it's much more effective. So you can never go wrong with substitution. So the first thing you do is you get the x, for example, and you're going to clear it out. So just moving everything around that equation to leave the x alone on one side. And what I'm going to do is I'm going to substitute in the second equation and put where I have the x, instead of x, I'm going to put what I just figured out in the other one. So I'm going to have minus big brackets y minus 1 divided by 2, all of it minus 2. Now, I just have to solve the equation now. Let's clear this up a little bit so it looks a little nicer. Realize how I separate the fractions just to make sure that I'm making no mistakes with the signs. Let's carry on over here in the second column. I'm going to take y divided by 2 to the other side, so I have all the y's together. Oh, this is more mistake there. It can't be minus 1/2, sorry. Let me go back. So the 1 plus y halves equals to 1/2 minus 2. So that's going to be 3y divided by 2 equals to minus 3/2. Now, if you think about it, the only thing I have to do is multiply by minus 1, and y must be equal to minus 1 to get it to be true. Now, what I do, step 3, is I go and find out what the value for x is. And I get it's going to be minus 1, 2. And hence I have my solutions to my simultaneous equations. Is that how you solve them? Thank you for watching. Goodbye.